All right. Good afternoon, everyone. Welcome to the latest seminar from the U.S. Society of Ecological Economics. My name's John Palomeni. I'm the president for about one more month. And we've been having a number of these seminars, and they've all been excellent. And the latest one we'll see today is by Mihai Mutascu, sorry.
Correct.
He's at the International Management Institute at Zurich University of Applied Sciences, as well as a faculty of economics and business administration at West University of Timisoara and the LEO in the University of Orleans. His paper will be presenting today is Beyond the EKC, Economic Development and Environmental Degradation in the U.S., and was recently published in the Ecological Economics Journal. So with that, I'll turn it over to you, Mihai, and thank you very much.
Thank you very much for your very nice and kind presentation introduction. I will kindly ask you if you see my screen. It's in full screen mode.
Yes.
Okay, perfect. So first of all, I would like to thank you very much for your kind invitation, John. It's a great pleasure to be here to present and to share with you my research results. My presentation today is about the impact of economic expansion and environmental degradation in the United States of America. More precisely, it's about in fact it's in a reevaluation of the EKC curve by using a new methodology, which is in time and frequency. Normally, in economics, we work with time domain in time series, but this is a time and frequency. And this tool, it's very recent. It's called the wavelet quartile correlation from 2022. So 2 years ago was proposed. Okay, let's start with the context, which is the context of this paper. The context is related to the United States of America for sure. We know that this country is one of the biggest economy in the world, experiencing economic growth over the years, but in the same time seems to be, and for sure it is, in the top 5 most polluter in the world. I may kindly ask you if you have my voice or because the internet here is very, very bad. I know I have an announce.
We can
hear me? All fine?
Yeah.
Okay, perfect. Sorry. And say that the US is in the top 5 most polluter in the world, and sure that having these characteristics, we can expect that this country to have a huge influence in both terms of climate and environmental policy. In this context, I try to revisit the connection between growth and pollution in US. I try to revisit, in fact, a nonlinear connection between those variables, testing the EKC curve, the environmental causes curve. I cover the period 1992-2022. I have the monthly frequency. As I already mentioned, I work with wavelet quantile correlation. And in terms of contribution, I think that to the best of my knowledge, sure, I think this is the first paper that used in the EKC field this WQC tool. What I obtained, first, I didn't confirm the EKC in US, but I found a very interesting results in short and long term. You will see that the core results show that in the short term, we'll have a negative correlation between growth and pollution, and a positive one on the long term, but with different magnitude. I propose you 6 parts that they are a classical one. I will start with introduction, with the literature. data methodology results. I have some robustness check, and I will conclude in the last part, offering sure also some policy implication. I'm going now to the introduction. The theoretical ground of the paper, I'm pretty sure that we know this. It's the contribution of Grossman and Kruger from 1991. It's based on their results saying that at the low level of income, there is a positive correlation between growth and pollution. And if the level of income increases, the sign of connection changes because we have the composite effect. So there is a movement from non-pollutant capacity to polluted capacity, sorry, to clean capacity, and also we have a technical effect saying that if you are more developed, you can produce more clean. Conclusion, if we put all together, both, let's say, the positive and negative connection, we can construct a nonlinear link between growth and pollution with the maxima. And in fact, we have an inverted V shape saying that if you expand more your economy, pollution increases, reach a maximum point, and after that fall. Having inspiration from Kuznets, Panayotou in 1993 named this the environmental Kuznets curve. In fact, it's let's say a reshape of Kuznets curve connecting the growth with income inequality. What happened over the time, starting with this contribution, there are many researchers trying to validate this nonlinear relationship and sure that results are absolutely heterogeneous. Many researchers prove there is only a linear connection with positive and negative sign. Another group say, no, we don't have an inverted U shape, we have rather a U shape. And even some strand of the literature show that there is an N shape, inverted A shape, and even M shape relationship. So if you look, in fact, we have two different strands, one claiming the linear connection and the one around the nonlinear one. What I try to do is to focus on the nonlinear one, this quadratic concave shape, assuming that we have a maximum in the link between growth and pollution, environmental degradation. Now, why US? Again, back to the targets. Why the reason why US? Again, I said that it's the top 5 world polluter. It's in the second position. We see in a while some stylus facts, some statistics. And major part of this pollution, the CO2 emission, more precisely, is generated by transportation, electric power, and industry. In the same time, as I already mentioned, there is in parallel, if you want, we have a steady increasing trend, particularly on the period I investigated from 1992. Sorry, this is 2022, it's not 2012, it's 2022. And also, very important, in this period, we have two, let's say, breakpoints. We have the financial crisis from 2008 and pandemic one from 2022, if you want. So I mentioned it because they are important in my result, in my presentation for that. Some stylus fact. This is the data showing the rank in 2022 in respect to CO2 emission. The data set came from the Worldometer, yes, Worldometer database. We can see that United States, it's posted the second in this rank. And if we have a look on both China and United States, they generate almost half of the world CO2 emission. If you want to see a little bit the dynamic, here's the dynamic of CO2 emission from 1940 to 2022. It's very important to observe that in the case of United States of America, and if we resume exactly on the period I investigated from 1992 to 2022, so from this point, it is very clear that we have an increasing trend over 2000 over here, you can see, but it's smooth one, and then with a smooth decreasing trend till 2022. And more, with two, let's say, shocks. We have this one. You can see very small, but it's this one from 2008. It's the French crisis, and we have the shock for pandemic one. And let's see now transporting in terms of our period investigation and with monthly frequency. In this plot, you have the CO2 emission per capita and the GDP per capita. And I'd like to mention that for the GDP per capita, I use the monthly data came from Standard & Poor's. It's a GDP per capita explained in chain type 2017. You can observe the same or almost the same dynamics. It's very clear the upward trend of GDP, the shock, financial shock here, and the shock for the pandemic. And if we have a look at the CO2 emission, CO2 emission rather present two, let's say, trend, one till 2000, increasing one, and another one descending toward 2022. In fact, if we observe, it is easy to observe that we have two different sign of connection. In the first part till 2000, we can assume that we have a rather, the variable can move in the same way. So we have a positive, let's say, correlation, then the sign change because one increases, another decreases. So, having this in mind, I think that it's important to give another approach of a relationship between growth and pollution, testing the nonlinear effect, the UKC curve. Keep in mind that we have trend, so we can say that we have a sort of long-run perspective, and we have maybe the structural breaks. We have a breaking point that can modify even in the medium term or in the short term this dynamic. So to this end, what I did, I think that, okay, it's important to see the sign between the variable, but, and maybe if you want, which level of scale magnitude this happened, but also if we assume we have a trend, we have also cycle for sure. And if we have that breakpoint, also maybe will be very interesting to see the short and long run perspective. Why? Because if we assume to have trend, if you assume having breakpoint, this means that the elasticity of movement between the variables seems to be different. Keeping in mind this, I tried to look for different tools offer me this perspective, and I found that there is this new, I may say, vanguard methodology called the Wavelet quantile correlation that allow you to filter what happened in terms of correlation across the quantiles, and also what happened in terms of correlation over different frequency. We can assume the short, we can assume the high frequency, a low frequency. Now, To understand a little bit the idea, in the wavelet, you have the high frequency that in economics mean the high frequency mean the short term, because we know that the frequency is the inverse of the period. So high frequency, low period, low frequency, high period. If you assume that you want to observe something which is on the it's on a low frequency, this means that you can assume that we have in economics long-term approach. Okay, to conclude here in introduction, target is to revisit this EKC curve with this tool over the already mentioned period. And in terms of contribution, I think that one of the first the main contribution is that offer a different perspective of the approach of EKC curve with very particular results discriminated between the short and long run. We can find some very interesting results, assuming that the low income represent the period with the pre-industrial era, and the high income, very high development, the post-industrial era. This is inspired with the EKC curve. And let's say the theoretical ground of this approach, and not least seems to be, to my best knowledge, the first paper offering this perspective of EKC by using with this methodology. Several words about the literature. Sure, there is a huge, not very huge literature in the field, with different targets, different countries, different group of country, different methodology, different period, different frequency, and absolutely sure different results. But as I already mentioned at the beginning, the results are split into my part. The first group said that we have a linear connection, positive or negative, and another strand invoked this nonlinear link. One of these, let's say, strand of literature claiming form or validating this inverted U-shape EKC effect. Unlike the main body of the literature, I propose, I follow, in fact, the Leal and Marquez 2022 paper, the review paper, splitting the literature in two fields and in two strands. One is dedicated for the single country approach, and the second one for the multi-country approaches. In the first case, dominantly we have a time series analysis. Many of these papers are empirical one, following the classical econometrics and time series. The second strand use more cross-sectional or panel data set. In respect to the first strand of literature, we have only one country. There is absolutely linear validation of the curve, particularly with the positive sign, meaning that if you expand more your economy, you generate more environmental degradation. There are a couple of papers validating this result, ranging for Bangladesh to Turkey, for example. We also have some EKC support. We can see here the validation in the case of China and Kenya, and very, very interesting, an N-shaped relationship. And now we move on the nonlinear approach, including also shorter EKC support. Say about the N-shaped relationship, it's a polynomial relationship in the case of Austria, and even no support for EKC effect. There's some paper validating this finding in the case of India, Tunisia, and Turkey. If we move on and we include more country, they are the most almost in the picture. We can then in the mirror, if you want, we have more or less the same conclusion. We have a linear connection with the positive sign, but in this case, they are validating working with panel data. We also have the EKC validation also especially in the case of OECD country and GCC country. Interesting, we have an U-shaped relationship. In fact, it's an opposite effect in a Latin American country, and link and shaped link dominantly for OECD, OPEC, and BRICS country. And we can also observe some mixing results with U-shape, inverted N, and M-shape, let's say, movement. This is a paper of Young et al. In 2015. But I did more. I tried to observe what happened in US in terms of AKC. I found these 4 papers. I consider that they are more influential, if you want. It's a paper of Soitas et al. Hope that my pronunciation it's correct. In 2007, say no evidence for AKC effect. This group of authors covered the period 1916-2004, and they use classical Granger causality. Conversely, if you want, it's the paper of Ongan et al. In 2021. They validate the AKC in the United States. They use in parallel with growth and pollution different controls to isolate the effect. And some mixed results came from Isik et al. 2019. There are 2 papers. If I correctly remember, they use at the level of state, they use a mean group model, and they observed that the AKC it's validated only in a couple of states, with 5-6 states. I think it's New York, Florida, Michigan, Illinois, and Ohio, if I'm not wrong. Also, I tried to review some paper in the AKC area, but using the wavelet methodology, we're using the time and frequency domain methodology. I found here 2 contributions. The first one is dedicated to the GCC region. It's a paper of Jamazia and Louis from 2015, and my paper with a group of colleagues from University of Bordeaux focused on the case of France. Unfortunately, only 1 paper are found using this new methodology, the wavelet quantile correlation. This methodology was proposed by Kumar and Padakandla 2 years ago, or 3 years ago. But the paper I found it's not related to AKC. It's focused on the impact of energy efficiency on carbon neutrality in India. So no paper, I didn't find a paper using this methodology to test the AKC, particularly in the case of US. At the end, I will mention some review papers, very useful review papers, especially the last one of Leal and Marquez from 2022. There is a general review, if you want, of the literature, including many country targets, different targets, methodology, both theoretical and empirical papers. And I also found only 1 paper reviewing the literature dedicated to the United States of America. And this is the paper of Mahmoud Juaneb in 2023. Good. Now, let's see. I will start with data. Normally, you expect to start with the methodology, but we start with the data. It's not a very big deal in terms of empirical strategy, because we have only 2 variables. we have a variable capturing the economic development. So we have the economic expansion, if you want, noted X. This is a real GDP per capita. I mix here two data sets. One came from Standard and Poor and another one from Fed. And the second variable, it's a proxy for CO2 emission. Sorry, it's a proxy for environmental degradation. It's a CO2 emission, also per capita. Mixing the data came from Edgar and Fred. I have a monthly frequency. Why from 1992? Because the real GDP per capita, it's officially offered by Standard and Poor from this period. So I didn't find a larger period in terms of with monthly frequency. And in parallel, because normally you have to try to validate in a different way your results, I check for robustness by switching here the environmental degradation indicator by using and the nitrous oxide per capita level. Also, I mix Edgar and Fred databases. I'm not a specialist in chemistry or in gas chemistry. I don't know exactly what is the field, but as I know, the CO2 emission, it's more related to the climate change, while nitrous oxide, it's say more details about the ozone layer depletion. I'm not sure that it's correct, but these there are the information I found. So more or less, both indicator capture environmental degradation. Sorry, just because it's important here, just to keep in mind that working in the violet, normally the series have to be non-stationary. So this non-stationarity is a requirement in the violet methodology. It's not like in time series. Even so, I extract the seasonal component of the series, and also I work with the first difference in their log form. Why the first difference? Because we know that you have a first difference, second difference, you can stationary the series. But I follow here a paper of Percival, who said that even if you have a first difference in wavelet in your signal, this is not like, let's say, a rule to try to stationary the series. It's rather related to the improvement of a variance in your series. So if you work in the valve, it's important to have a very good variance, very high variance, in order to capture both high frequency and low frequency in your estimation. This is the plot of the scatter plot, in fact, of the series. We have the GDP and level log and the CO2 emission, both in per capita. You can observe that there is a clear a sort of nonlinear relationship, if you want, by polynomial form. That's why, because of this, I assume that we can follow a nonlinear test, and particularly the EKC effect, so the nonlinear relation by inverted U shape. About tool, this is a tool by Kumar and Padakandla, as I already mentioned, 2022. What the tool allow you to see what happened in terms of correlation across different quantile. You'll see that I work with the percentile, and not only to see what happened across the quantile, but to see what happened in terms of frequency. Again, don't forget, high frequency mean the short term and the low frequency mean the long term. So why we assume this? Because again, we can have fluctuation on the short term between the variable, and mention here the policy changes, economic shock we have, and also the long term. And this is rather related to the technological scale effect. We have the technological advancement and maybe structural break in the data. Therefore, to conclude here, the tool allows you to see what happened across the quartile in terms of sign and magnitude of correlation, and also what happened in terms of, let's say, horizon perspective, short term, long term. This is very important in my investigation. This is the master formula of this let's say wavelet quartile coefficient. It's not a very big deal. It's just a classical correlation in quartile from time domain, time series, but with adjustment of the series. If you look here, this is a X series, Y series, meaning this is GDP per capita, this is CO2 emission. You can see that D and G represent, in fact, the wavelet coefficient calculated across the quantile. In fact, that methodology have two steps. In the first step, you have the time series, the signal. You split the time series in quantile, in my case in percentile, and then you will transform each quantile by using the high pass filter and low pass filter. And you repeat this iteration many times as you finish all this, let's say, the wavelet transformation. Normally, this is not continuous wavelet transformation, it's discrete transformation proposed by Percival and Wout. I hope that my pronunciation is correct. Meaning that you use a wavelet. It's not very clear, honestly, for me, what the wavelet the author proposed, Kumar and Padakranda, in this tool, because in the original paper they didn't offer some information. But as I observed, I suppose that it's a Dubashi wavelet. And filtering each quantile, you obtain, in fact, the wavelet coefficient. So what we have here represent the wavelet coefficient. It's very complex process. And then there is a correlation across the quantile. Now, let's see the results. And this is the result. I know that for the colleague who observed for the first time that this wavelet technique, it's pretty fine because we have a color, so it's like in cartoon. How we interpret based on the color. In fact, what we have here in the right side represent a legend. You can see that we have a dark violet and a light, the dark violet and the light yellow. This means on the top, the very high correlation, and what we have in the bottom here, it's very high correlation, but inverse with the negative sign. So you have the positive correlation and the negative correlation. So if I try to interpret something to violet or the dark violet, I know that it's an inverse correlation. I know that we have a negative sign between the variable. If I have the yellow correlation, okay, the positive correlation between the variable, for sure that the color I expect it's this yellow one. This is one point. So just try to follow the colors. Negative one, violet, dark, very positive one. Let's say in terms of magnitude, is this yellow light. Now, back to the plot. In the plot, on the horizontal axis, we have represented the quantile. We have the percentile here. This is the middle, okay? This is 0.5, it's 15% quantile, percentile, sorry. And what we have in the vertical axis represent the frequency. But why the frequency? It's liberated in period. Keep in mind that frequency is in inverse of period. So if I assume that I have here 4 months, in fact, my frequency, it's 1/2. In reality, it's 2p/2, but it's 1/2. So I have 0.5. If I'm going to the top here, 256 months, why month? Because I have the monthly data set. The frequency, you see, it's 1/256. It's lower in this part. So as I move in the top, the frequency start to increases. If the frequency increases, the period it's high, meaning that I can assume without any doubt that I have here the long term and here the short term. In fact, if we follow the economic, let's say, rule, 12 months, so this is part here, this represents a high frequency, inverse of time, and I know that being up to 12 months, this means the short term, short run. So I have a short run here till 12 months. Starting with 12 months, and I'm on top here, I can assume that the frequency start to decreases, progressively decreases, and for sure that perspective, it's rather on the long term. So to conclude here, this is the short term, this is the long term, high frequency and low frequency. Moreover, just have a look at the colors. Dominantly, if we follow here the short term, you can observe that we have the violet color. So we know that the violet means the negative correlation. One variable increases, another decreases. And also, if you look at the middle percentile here, seems to be more intensive. So we have a dark violet. If you look on the left side to the middle and the middle to the right side, the color is very intensive in the middle of quartile. So I suppose that I have here a negative connection between the growth and pollution, but the magnitude start to increases towards the middle quartile. Otherwise, differently, if you have the right side, for the middle quantile to the right side, you see that I have an intensive or dark violet, which became light to the right. And if I follow my percentile here, this means low income, and this means higher income. Lower income, pre-industrial stage, I can suppose this, and higher income mean post-industrial stage. To conclude here, in the short term, what I have in the middle, in fact, I can expect to have the peak. So that's the maximum industrialization in this country. Now, let's move on the long term. Now the color changes slightly, not slightly, but changes. We have yellow color, and the light yellow seems to be concentrated again on the middle of percentile. It's over here. So if you look on the left side, I have a positive correlation, but the magnitude is lower than here. And if you look on the right side, the magnitude of positive correlation start to decreases. If you put together, it's something similar. So I found that in the left of for the lower quartile, pre-industrial period, low income, I can expect to have in the long term, I can expect to have only positive correlation that increases as we reach the middle of quartile, the middle of percentile here. And this correlation progressively reduced in terms of magnitude if the income increases more and more and more. In fact, we have two different stuff. One, a negative correlation in the short term, and we have only positive correlation long term. You can see that this perspective, by using the Waveley-Quantet correlation, the results are completely different in terms of if you want to compare with the EKC classical approach. In EKC classical approach, you don't have this short and long run perspective. You have the left side of the maxima, you have the left side, the positive correlation, the right side, the negative one. Here we observe that we have only negative correlation, the short term, and the positive one only in the long term. And now, what I did next, I transposed this picture with color into 4 figures. What you have in the left side is in fact the pre-industrial period, pre-industrial era. Why? Because we are in the low income. So this corresponds to this part on the left side of the middle percentile. Okay. Why? Because they have a low income, and we have a low percentile. And what you have in the right side here, you can see that we have a post-industrial era. Why? Because we know that we are a high percentile, we have a high quantile, okay? And I observe this. The magnitude more accentuated and negative in the middle, you see? More accentuated. Let's say the slope, okay? It's more accentuated toward the middle. This is the middle of the middle quantile here, in this part. The same happen if we move on the long term, more than 12 months here, this part. You see, positive one, very accentuated, look, increases, less and less, and that more and more and more, and then increases, less and less and less, and less and less, and so on. So, based on the plot I generated with that tool, I create, in fact, 2 different era, if you want, the post-industrial and pre-industrial and post-industrial, with different perspective, short run and long run, and different magnitude of dynamic regarding the link between growth and pollution. It's completely different if we want to compare with the classical, let's say, EKC effect, which is a nonlinear, but it's like a Gaussian bell. Next, and I will finish with my results here to present the results. This is a robustness check. So this plot, in fact, show you the results replacing the CO2 emission with N2O emission. You can see more or less the same stuff. Do you see a -1 here, very intensive, because it's a dark blue here, but minus, and +1, but there is a sort of delay, you see? So we have the results here, look, and we have the results here. So the negative sign I have here it's reported for more than 128 months. What means this? This doesn't change my dynamics, let's say, results, but showing me that if I use gas, different proxy for environmental degradation, seems that there is a difference between using the CO2 emission and N2 emission. So we have a sort of delay in terms of propagation of the effect when the economy expands. So the effect seems to be more quick in the case of CO2 emission, and with sort of a delay, but huge maybe in terms of N2 emission. Honestly with you, I didn't try to find maybe it could be another investigation to find why happened this, and why what kind of I don't know to say characteristics have these 2 gas as a reaction to the economic expansion. I'm absolutely sure that there is some explanation. Now I have to conclude. I split my conclusion in 2 parts. We have the pre-industrial era with the short and long term. So what I have here are the conclusion came from this figure here. And I have another conclusion in the post-industrial era. They are related to this plot here, this figure here. What I say is that if we follow the pre-industrial era, so we are in the low quantile, we have a low income, we have a small economy, okay, at the beginning. We can say that in this case, the expansion can reduce the environmental degradation because we have subsistence agriculture and environment is not saturated, so it can absorb very easy the gas emission. Maybe more accentuated, it's in the final phase, in fact, of this short-term perspective, because we can assume that even if we have agricultural activity, the people start to be more aware about the environmental degradation, and maybe they start to use more clean agricultural, if you want, techniques. On the long term, we have only strict positive correlation. In the first phase, the sign, the positive effect, it's quite low because agriculture on the long term start to generate pollution, and we don't have many, let's say, alternative technique and practice to counteract this environmental degradation. Further, if as much economic expansion increases, you expand more economy till we arrive or the reach the industrial point, for sure that you generate more and more pollution because the magnitude increases. You remember for this part, very intense light yellow. And this situation is I already mentioned here, it's a wave of industrialization. We don't have only industrialization, we have a very high population growth, we have urbanization, and maybe we are not prepared to adopt a less polluting technology. Conversely, in the case of post-industrial era, in the short term, the pollution it's still high in the first phase. Because I said that we use less the polluting technology. There is a delay between invention and use of that technology. And we said that maybe environmental policy reach their maximum efficiency in terms of policy with the short run, on the short term effect. In the final phase, the reduction reduced a little bit because I'd say that this transition to service-based economy, maybe some stringent regulation in the short term can't reduce but less environmental degradation. On the long term, sure that in the first phase, economy expand more, we have more industrialization, urbanization, much more population, and we start to use the new technology, less but clear technology, and maybe adaptive environmental regulation. But this cannot, let's say, compensate the effect of development. Finally, there is some improvement in the last phase of post-industrial era, saying that in this situation, the use of clean technology and, if you want, the more stable policy strategy seems to start working, but without sure eliminating the level of pollution. Overall, if you want, I prove in this paper that in the short term you can expect to have some, let's say, reduction in terms of pollution if our economy expands. But this depends rather by our behavior and maybe some policy measure. But on the long term, we always will have, irrespective if we are in a pre-industrial, industrial stage, always economy will generate pollution. In fact, it doesn't exist solution, because if you think about the EKC curve, do you remember it? If on the right side of the curve, if you expand more your economy, the CO2 emission, the pollution reach even the 0 point. So in this study, I proved that there is an asymptotical tendency trend towards the zero, but never ever will not reach the zero pollution. That for sure, and I am pretty sure that you agree with me. I will have some policy implication. They said that in the early stage of economic development, it's important to have a look on the clean agricultural practices and maybe to try to use some less polluting energy sources. In the pre-industrial to post-industrial stages, it's important to have a look at the investment in clean technology to stimulate an R&D and some policy helping this transition to service-based economy. And finally, if I have to design some policy for the post-industrial era, it's important only to maintain and strengthen the environmental policy, stimulating the green technology and investing, I say, in renewable energy infrastructure. So this is my all talks today. That's all, folks. And thank you very much for your attention. And yes, if you have any comments or suggestion, you have my email here. And now I'm waiting your question, or I don't know. Thank you.
Thank you. That was a wonderful presentation. We have a few questions.
Yes.
Alejandro, why don't you go ahead?
Sorry? Yeah, no?
Oh,
I didn't.
I think there's something wrong with his microphone, maybe. So I'll just read it.
It's unmuted.
Yeah, it says, thanks for your presentation. The questions are, could the shape of the EKC change if different pollutants were considered? CO2 and N2O mainly represents air pollution, yet environmental degradation also includes water, soil, and noise pollution. And
Yes.
could a comprehensive unified metric encompass all these factors? And if so, would the EKC still follow its expected trajectory?
Yeah, sure. This is a very nice comment I already received during the review process. I received, in fact, two very interesting comments. That was one of them. If we change the type of proxy, for sure that the results a little bit change, because environmental degradation doesn't mean only the gas emission or CO2 emission and N2O emission. I absolutely agree with you that if we change the indicator, there is some let's say change, if you want, in terms of result. But what I did is to prove with let's say an alternative gas emission, that I say I'm not a specialist in this stuff, that there is almost the same dynamics, but sure with delay. You see the delay, there is a delay between in terms of reaction if we work with CO2 emission compared with nitrous oxide. But I absolutely agree that if we change the indicator, we can expect to have maybe different result. It's very nice comment. Unfortunately, I didn't find, honestly, with you, it was very challenging to find data with monthly frequency. Um, and also maybe, to test the robustness check by using with the quarterly frequency to have more option in terms of robustness check. But I think that this is a beginning, at least in the EKC, let's say the wavelet perspective. Particularly in this quantile, because if you work with wavelet cohesion, this is another tool. Sure, the perspective is different. But to finish, yes, I completely agree, and could be a very nice next research to test different proxy for environmental degradation. I totally agree with you. Thank you.
Are there any other questions or comments? See if anybody has anything. I have,
Could you elaborate a little bit more on the pre-industrial definition of an economy and post-industrial definition of an economy a little bit?
Yeah, in fact, what I follow here, it's exactly, let's say, the mainstream in terms of what mean pre-industrial era and post-industrial era in respect to EKC curve. The pre-industrial era mean that economy is at the beginning. It's agricultural based. We base more on production till we arrive at when we reach the point of industrialization, and after that, the post-industrial era mean that you try to produce more with less polluting capacity, and the economy change because we have that composite scale change from the services based economy, and the level of pollution start to decrease. Yes, maybe your question is related to why I use, we have a United States of America. It's a country not in pre-industrial era, and we have 2092 and 2022. And I said that, look, we assume that we have a pre-industrial era and post-industrial era, but my investigation, it's about US, that it's not in pre-industrial era. So I adapt this wavelet approach, because one particularity of the wavelet is to work with to interpret historical facts. So supposing that for the low quantile I have this effect. Okay, the low quantile means economy at the beginning, and the high quantile, high percentile, mean economy very well developed. So that was the idea of this paper. But if this is your point, I don't know.
Yeah, that's interesting.
Absolutely agree. Yeah, sure. It's US. It's it's a very developed country. You can say that. Look, we are in 2022, and we discussed about the pre-industrial era. For sure not. But
well,
yeah,
not quite, because
yeah.
I was actually thinking in terms of native nations on their treaty lands. We have 574 native sovereign independent nations within the United States contiguous territories. And on a lot of those lands, incomes for native people are extremely low.
Okay.
And I mean, if we just think in terms of
I get you.
environment,
I get it. Very interesting.
Yeah, if we think in terms
Very
of just
interesting.
environmental degradation, it seems to me that the policy of the United States is always to export its environmental degradation on native lands. Here I'm thinking of the decisions to put pipelines on native lands through their
Yeah.
territories as opposed to major metropolitan areas with higher incomes. So I'm thinking like, I'm thinking that's kind of where my question lies, because here I view through your framework of pre-industrial, post-industrial, I see sort of like a tale of two cities.
Yeah.
And
The rich one and the poor one. Rich one and the poor one, maybe.
Yeah. And historically, you know, the federal government has always treated poorly Native nations. I mean, a book that just comes to mind, you know, that won the National Book Award was Ned Blackhawk's The Rediscovery of America. And, you know, his underlying thesis for that book, one of them, is about settler revolutions, basically economic expansion. And that's basically, you know, that whole idea of economic expansion serves as the modus operandi of moving east from the Atlantic to west. So that's why I bring it up.
Yeah. Okay. That's very nice and very nice idea. But honestly, I don't know if I will find the data, you know, because normally you have many advantages by working with wavelet, but one of the limit of if you want a disadvantages is that you cannot use at least in this tool more than two variables, the bivariate, you know. So sure, do you see? I don't have a control here to isolate a little bit the effect, but uh, uh, I'm wondering if I would like to see this, let's say, to test this heterogeneity in terms of the income. No idea if do you think that you know better than me? There's some data I can find the data set because I need I cannot work with the annual frequency. You need a monthly, quarterly frequency, even daily frequency. Do you think that there is available some data across the state, or I don't know?
Well, yeah,
Just
it's a little convoluted because the U.S. Census Bureau, I think, just includes it. It may or may not include the breakdown of income by Native nations, because Native nations aren't a race. You know, they're a sovereign, independent nation. So I'm not sure if the U.S. Census Bureau breaks it down by white, black, Latino, Hispanic, you know, but versus by each independent nation. And if it does, it might not be with the U.S. Census Bureau, it might be with the Department of the Interior.
Yeah.
Because the Department of the Interior historically has been the historical agency which works with Native nations.
With the Native nation, okay.
Yeah, and before that was the Department of War.
Yeah.
So I mean right away, I kind of see the framework that you're working in, but the story is very different from another perspective, that of the Native nation. But yeah, to wrap up the GDP income, U.S. Census Bureau maybe, depending on how they defined it, and if not, probably with the Department of the Interior. So
yeah. I see. Okay, thank you very much. Very nice comment and idea. I really appreciate
yeah, it's quite interesting. Thank you.
Thank you.
All right, so we are out of time, but I want to thank you, Mihai, for the wonderful presentation. Very informative and thought-provoking, and really want to thank you for taking the time to do this for us. So thank you, and wish everybody a very nice weekend.
Thank you, and hope to see you soon.
Thanks.